In this video, we'll be discussing ARM thumb mode. By the end of this video, you'll understand ARM thumb mode and be able to write some assembly that uses it. The ARM processor has two operating modes, ARM mode and thumb mode, both of which the processor can change between during code execution. By default, the processor operates in ARM mode, where the instructions are 32 bits wide. Thumb mode is a mode on the processor where the instructions are only 16 bits wide. What this means is that an instruction, such as this one, add R1 plus R0 into R1, the ARM mode instruction would normally be 4 bytes long. Instead, in thumb mode, this same instruction can be boiled down to 2 bytes. The developers of the ARM architecture realized that the 32-bit instruction had a lot of empty space in the instruction that didn't carry any valuable information, and then created thumb mode. So what does this mean for programmers? By using thumb mode, the code will generally take up half the memory, saving flash and RAM in places where memory constraints are a concern. Also, because of the reduced amount of RAM accesses and instruction cache misses, the processor uses less power in thumb mode. Having thumb mode is a good tool to have in your back pocket if you're trying to make your code more efficient. So the question then would be, why not just use thumb mode all the time? With a reduced length in instructions comes a reduced functionality. Thumb 1 mode, the original thumb instruction set, can only access the lower half of the ARM registers. Also, it has limited functionality on its branching instructions. There's also a thumb 2 instruction set, which enables the processor to weave in some 32-bit instructions during thumb mode to add more functionality, but not all ARM processors can do thumb mode with thumb 2 instructions. So, how do you put the processor into thumb mode? Normally, ARM instructions are 4-byte aligned, so the last bit of the destination address for a branch is always 0. By flipping that bit to 1, that signals the processor that at that address, the processor will be executing in thumb mode. From that point on, the processor reads in and executes instructions 16 bits at a time. In this example, we're going to sum label plus 1. The processor will go to sum label, but execute sum label's instructions in thumb mode. Okay, so with that being said, let's jump right into the code. For those of you that want to follow along or mess around with the code after the video, do me a favor and go check out my GitHub, github.com/lowlevellearning. I will have the code up there after this video goes live. Also, I noticed that almost 90% of you who are watching this are not subscribed. Do me a favor, go hit that sub button, be alerted whenever I put out new videos about low-level topics. So here on the left, I actually have the source code from my first ARM assembly tutorial. This is a hello world that you remember. Remember, you run it and it prints out hello world. What we're going to do is we are going to copy this code and we are going to make it print hello world twice, but it's going to have to run this hello world in thumb mode, and then it's going to have to exit thumb mode to call the exit to get out of the programs. Basically, the states will be hello world in thumb mode, and then we'll exit in ARM mode again. So the way that we have to first tell the assembler that we want to put our code into thumb mode is by typing simply .thumb. So that actually tells the processor to do everything south of that instruction in thumb mode. So we can actually assemble that real quick with the assembler, and then we're going to object dump that object file. That'll print all the code in that object dump to the screen, and we can actually see what the bytes look like for that code. So here we have our start label. As I said, the processor starts in ARM mode. All of the instructions are 4 bytes wide. And then once we get to hello world thumb, it actually goes into thumb mode, which is pretty interesting, right? All of the instructions are 2 bytes wide. But there is a problem here where the exit is still in thumb mode, and that's not what I want. I want it to be in ARM mode for the sake of this tutorial. So I have to tell the assembler to put it back into ARM mode with .arm. So now start is in ARM mode, hello world is in thumb mode, and then exit is back in ARM mode again. But if you actually run the code like this, right? So you assemble it, you compile it, and then you run it, you're actually going to get a really weird error. So it's going to compile and run correctly, but you're only going to get one hello world. That is because the code for the second hello world is in thumb mode. It's compiled or assembled for thumb mode, but the processor doesn't know to go into thumb mode. So when you actually object dump your code, the disassembler shows you the code as thumb mode, but there's no transition from this instruction to the next to go into thumb mode. So this actually all gets ran in ARM mode, and these aren't invalid instructions in ARM mode, they just don't actually do anything. So the processor kind of runs over them, somehow doesn't crash, and then gets to the exit code, which is in ARM mode, and exits. So we need to create this glue here to enter thumb mode and exit thumb mode. And the way we're going to do this is we are going to create that glue. So we're going to load into R0 the address of hello world thumb. And then, like I said before, to get into thumb mode, we need to actually increment that last bit of the address that we're jumping to by 1. So we're going to add into R0 plus the constant 1. And then we're going to branch exchange R0. So assemble, compile, and then we'll run. Okay, great. So now we got that second hello world. So the first hello world, let me object dump this for you. That first hello world ran. It printed the data to the screen. Then we set up our jump into thumb mode. Thumb mode entered at hello world thumb at this address. Remember, we jumped there +1 to turn on thumb mode. And that printed out the second hello world. But then the processor is in thumb mode trying to execute ARM code. These blocks of 4 instructions are not valid thumb, so the processor crashes. So we need to do the exit glue code to get out of thumb mode. So let's knock that out real quick. It's kind of the same idea, except we don't do that final add, right? We don't tell the processor we're in thumb mode anymore. So we're going to load into register 0, exit, and then branch exchange R0. Cool. So we ran it. We were in ARM mode here. We printed hello world. We were in thumb mode here. We printed hello world. Then we jumped out of thumb mode, back to ARM mode, and we said, get out of here. Do me a favor, hit that thumbs up button on this video. I really appreciate it. But hey, I hope you learned something in this video. If you did, do me a favor, hit that thumbs up button, hit subscribe, and I'll see you guys in the next video. Thanks for your time. Bye-bye.